If a new class of materials, like Equinox materials, shall be tested, it is important to have enough standards for comparison. As standards, we use different steel qualities, pure aluminium and a casted iron aluminide. The most important step in the beginning is the sample preparation. In best case, the sample is completely dense, showing no porosity at all. We try to keep the geometrical surface area that is attacked later on in the cavitation test constant for all tested samples. In our case, it was approximately 130 mm square. Because cavitation erosion behavior heavily depends on the surface roughness, it is important to treat the surfaces of all samples the same way. After grinding, we used to clean in a 50 watts ultrasonic bath for 5 minutes in acetone. So in the glass there is acetone and 5 minutes cleaning. After the cleaning in the ultrasonic bath, we used to dry the sample on air. After drying, the sample is brought to the balance. The balance is placed in a room with controlled temperature and air humidity. We try to keep temperature and humidity constant. For comparison, we always also weigh the standard weight. This first measurement of the weight will give the starting point of the final curve. After taking the data for the starting point of the final curve, we can go on and expose the sample to the cavitation erosion. We tried out different sonotrodes and ultrasound generators during the project. It finally turned out that a sonotrode with a 200 watt ultrasound generator worked best. The sonotrode has an exchangeable tip made of titanium alloy. The sample is fixed in the sample holder and put into the electrolyte. We usually used tap water. The temperature was held constant at around 20 degrees Celsius plus minus 1 degree. We also tested in distilled water, seawater, acids and other liquids. The used liquid has a big influence on the final erosion, since chemical effects will overlap with pure cavitational effects. At the tip of the sonotrode, cavitation bubbles will be produced. The bubbles will collide with the surface of the sample and collapse. Due to the collapse of the bubbles, microjets are formed that hit the surface and attack it. Depending on the material quality of the sample, more or less material will be eroded from the surface. After a defined period of cavitation erosion, the sample is taken out and cleaned in the acetone ultrasound bath for 5 minutes again. Then it is weighed. This will give the second point of the mass loss versus time curve. The final graph of the mass loss is unique for each tested material. Within Equinox, we used only the linear part of the curve for further calculation. A regression can be calculated for the linear part. Usually this linear part starts after 40 minutes of ultrasonic exposure. Final value for the cavitation erosion resistance, the RE value, can be calculated from the formula from the mean erosion rate. All RE values from different materials line up, starting with the weak on the left side and the strong on the right side. New materials like the ones we developed in Equinox can easily be judged by looking at their position in the row. Other setups like hydraulic tests should give the same line-up of the row, but can actually differ in the values of the numbers for the measured and calculated resistances. I hope you got an impression on the characterization method. For more information on the topic, look out for further Equinox dissemination activities. Goodbye.